You saw the title. December 19th is our truth day for 3i/Atlas.
We've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system. Take a look at this. This is 3i Atlas. You know how the last time we talked about it, it went behind the sun, then it got brighter, then it got bluer, then it started to go faster, non-gravitational acceleration. That's what we were thinking we were going to see. So let's get straight over to Harvard astronomer Professor Avi Loeb, the world-renowned expert on all these things, all things interstellar. Well, guess what? We just got new images of it, and to add some more strangeness to the 3i Atlas saga, because, like, I don't want to overhype this, but yeah, you see, that's a comet. It does not have a very big, very noticeable cometary tail.
Here's why you should care. 9 anomalies stacked like a perfect storm. Trajectory tuned to skim planets with only a sliver of natural odds, nickel without iron, and a glow that turns an impossible blue. Think of it like finding a trophy fish in a dead tide with the wrong bait, and watching it break your reel. We're pulling the high-res data net today. Stay with me and I'll show you what to watch for in the December images so you can tell rare catch from rigged game.
Professor, the last time we spoke, which was like the day before yesterday, you were saying that when it went behind the sun, the natural explanation for the non-gravitational acceleration and the thrust might be because it burned off a bunch of chemicals or something, and that was giving it the thrust.
We see other comets in the solar system that have a beautiful tail away from the sun. Behind them, Lemon is an excellent example. But in our case of 3i Atlas, it looks like a fuzzy ball of light.
What is going on?
Yeah, that's very surprising because there should have been a very massive cloud of gas and dust around it based on what we know about comets. In fact,
before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great! Thank you so much. Now, back to the video. Out on the water, you've seen a dead tide give up one freak catch. Swap the bay for space. Atlas came in fast, hugged the ecliptic like a skiff riding a narrow channel, and set up a string of near passes that seasoned skywatchers flagged right away. One glide, too many buoys touched. The core claim is simple. An interstellar arrival took a lane that lines up encounters instead of spreading them out.
Even after it passed through perihelion, it was heated by 770 watts per square meter, and we know that the previous plume of gas was mostly carbon dioxide by the solar radiation and the solar wind, but we don't see that. So the question is, what's going on? One possibility is that what evaporates from it are fragments of ice, and they get vaporized by sunlight, and carbon dioxide ices can sublimate at a much lower temperature than water ice. So we should have seen it break up, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun.
That geometry doesn't happen often by drift alone, and it showed up right when eyes were on it. So let's dive in. The path stays low to the plane where the planets cruise. That funnels encounters. Think of a long, smooth swell that matches your hull speed. Your boat doesn't fight the water, it sits in it and keeps hitting marks. With Atlas, those marks are clustered windows. The stated odds for that alignment ran tiny. Pair that with a reported inbound speed on the order of 61 kilometers per second, and the setup stops feeling like a lazy roll in deep water. That said, trajectory is just one net. Chemistry tossed the next curve. Early spectra flagged nickel lines where you expect iron to shout as well. But the iron stayed shy while carbon monoxide lit up the scorecard. That's a strange mix for a comet. Standard play calls for both metals to show in sync if the grains are hot and dust is rich. Here, nickel peeks through and iron keeps quiet, while CO drives the gas flow like a strong outboard.
Before they have a chance to turn around and show up as a plume of glow behind it, away from the sun. That's one possible interpretation, but otherwise I just don't know what to make of it. So what I'm saying is, there are things we don't fully understand about this object. That's what makes it exciting, and I think all of us will wait for the data that will come in the coming weeks. There was also a blue color that was noticed just a few days ago, and also, in addition to that, it became brighter by a factor of 5.
Use one clean analogy. A tuned drift that tags 3 buoys with no touch on the rudder doesn't sell as luck. Each buoy is a close pass. If wind and tide push you true, fine. But add a 4th, then a 5th, and even old hands start checking for a hidden motor. Atlas's glide has that feel. The more aligned moments stack, the less room chance has. Now fold in the research angle we can point to without dressing it up. Interstellar guests are real, the sky has logged them before. But this one piles conditions. The inbound speed sits high, the alignment window got pegged at a fraction of a percent, and that geometry packs encounters together. When a track both schemes the main plane and stays steady through it, you get a crowded calendar of chances to nudge or be nudged. That's the deck, stacked. Back to the tackle box. The chemical fingerprint doesn't match the usual kit. You open it expecting 2 metal lures at the top, nickel and iron, plus a spread of water-driven lines. Instead, nickel is there, iron is not, and carbon monoxide runs the show. Multiple instruments fed that read out into pipelines and flagged CO dominance early, with the nickel/iron mismatch riding along. For a comet closer to the sun, water often calls the tune. Here, CO takes the lead, which says cold-borne ices or a different blend of grains. Because of that, the color story matters. Reports had Atlas swing from red to green to a bold blue near perihelion, with separate spacecraft pipelines agreeing on the shift. Color ties to gas and dust signatures. Green often tracks with certain radicals breaking down. Blue can spike when specific emissions take over or when dust grain sizes change fast. A rapid cycle through those hues in one stretch hints that the load coming off the surface isn't standard. Now pull the threads tight. Odd path. Odd gas. Odd glow. When 3 nets haul up the same kind of strange in the same week, you stop shrugging and start asking what set the drift. Natural chains exist, and they can fool you once. But 3 aligned tells deserve a closer look at cause, not just coincidence. Next up, we test the cleanest natural fallback, outgassing as thrust. If CO jets kick like a small rocket, the coma should grow thick, the tail should steer a bit, and the motion should twitch off the gravity line. The December frames need to show that, or the rocket story loses water fast. So here's the clean read. December's high-res frames act like a deep scan. If Atlas stays blue and the area around the core looks thin, the natural rocket story fades fast. Outgassing needs a heavy coma to push, no cloud, no thrust. Watch for 3 tells. First, persistent blue over several frames. Second, a dense dust and gas wrapped tight to the nucleus. Third, any motion that strays from the gravity line. Weigh those signs, not the hype. If this shifts you from rare catch to rigged game, subscribe and come back. When Juice drops its layer, we'll set the hook and test what really drives this thing.